Title: Chronodynamics and Causal Architectures, the Physics of Now, Then, and Never. Introduction: the bifurcated nature of time. I want you to look at your watch or the phone in your pocket. That device is lying to you. It tells you that time is a steady drumbeat, tick, 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 universal, unchanging, and marching in one direction. But as we stand here, closing out the research cycle of 2025, physics tells us a very different story. Time is not a drumbeat. It is a landscape. It is a dimension that can be stretched, twisted, and perhaps, just perhaps, looped back upon itself. Tonight, we are going to talk about chronodynamics. That is the fancy term for the mechanics of time travel. And I am going to be honest with you right from the start. The state of time travel physics today is a tale of two realities. It is a bifurcated field. On one side, we have forward time travel. This is not science fiction. It is an engineering reality. We do it every day. We have proven with staggering precision that we can warp the flow of time into the future. On the other side, we have backward time travel, retro-causality. This is the battleground. This is where the laws of general relativity clash violently with quantum mechanics. It is a realm of paradoxes, forbidden geometries, and, as we've seen in the last 2 years, some very high-profile scientific scandals. Over the next hour, we are going to dissect the latest breakthroughs from 2024 and 2025. We will look at how a lab in Colorado proved your head is older than your feet. We will look at the new theories of wormholes that don't require magic to work. We will discuss the retracted theory of everything that fooled the media. And finally, we will ask the ultimate question: does the universe have an immune system that prevents us from killing our grandfathers? Let's begin. 2. The relativistic framework, geometry as destiny. To understand time travel, we have to stop thinking of time as a background clock. We have to think like Einstein. In general relativity, GR, space and time are woven together into a fabric called space-time. Imagine a trampoline. If you place a bowling ball in the center, the fabric curves. That curvature is gravity. Einstein's genius was realizing that this curvature doesn't just bend space, it bends time. 2.1. The plasticity of time. This leads us to time dilation. The stronger the gravity, the slower time moves. If you were to stand next to a black hole, where gravity is immense, and I stayed here on Earth, you might wait there for an hour. But when you returned to Earth, you would find that decades had passed for me. You would have effectively traveled into my future. Now, you might say, that's nice theory, but does it affect me? Absolutely. It governs the global infrastructure you use to drive here tonight. The Global Positioning System, GPS, relies on satellites orbiting Earth. Because those satellites are further away from Earth's mass, gravity is weaker for them. Their clocks tick faster than the clocks on your phone by about 38 microseconds a day. If engineers didn't program the satellites to account for this relativistic time travel, the GPS accuracy would drift by kilometers every single day. Google Maps would drive you into a lake. Relativistic time travel isn't fiction, it's a logistics requirement. 2.2. The JILA Breakthrough, 2022 to 2025. But here is where 2025 changed the game. For a long time, we thought we needed satellites or black holes to measure this. Enter JILA, the Joint Institute for Laboratory Astrophysics in Boulder, Colorado. Between 2022 and 2025, they revolutionized what we call atomic clock interferometry. In the past, to measure time dilation, we needed to put a clock on a plane or a satellite. JILA built a clock made of a cloud of 100,000 ultra-cold strontium-87 atoms. They trapped these atoms in a grid of laser light, an optical lattice that looks like a stack of pancakes. They measured the ticking rate of atoms at the top of the stack versus atoms at the bottom. The distance between them, 1 millimeter, the width of a pencil tip. And guess what? They found a difference. The atoms at the bottom, being 1 millimeter closer to the center of the Earth, were experiencing slightly stronger gravity. They were ticking slower. The precision was 1 times 10 to the power of negative 21. Do you realize what this means? It means time travel is happening across your own body. Because your feet are closer to the Earth than your head, your feet are aging slightly slower than your brain. We have now confirmed general relativity at the scale of a grain of sand. Forward time travel is a verified granular fact of nature. 3. The geometry of backward time travel. So we can go forward by slowing down our clocks. But what about going back? What about fixing a mistake? What about saving a loved one? In physics, a time machine is called a closed time-like curve, CTC. Imagine your life is a line drawn on a piece of paper. Usually the line goes straight. A CTC is when you curve the paper so the line touches itself in the past. 3.1 rotating black holes, Kerr metric. How do we curve the paper that hard? We need rotation. We look to the Kerr black hole. This is a black hole that spins. When a massive object spins, it drags space-time along with it, like a spoon stirring coffee. This is called frame dragging. The theory suggests that deep inside a rotating black hole, past the event horizon, there is a region where this stirring is so violent that the directions of space and time swap roles. The future is no longer a time, it's a direction in space, and time becomes a loop you can navigate. However, there is a catch. The event horizon is a one-way door. You can go in, you can theoretically find this time loop, but you can never come back out to tell us about it. It is a time machine that traps you forever. 3.2 The Tipler cylinder. In 1974, physicist Frank Tipler proposed a workaround, the Tipler cylinder. Imagine a cylinder of infinite length spinning at near light speed. The math says this would create a frame-dragging effect on the outside of the object. You could fly a spaceship around it in a spiral and arrive back before you left. The problem? The math requires the cylinder to be infinitely long. If you cut it to a finite size, you need negative energy to stabilize it. And that brings us to the biggest headache in theoretical physics. 4. The wormhole conundrum. If black holes are traps and cylinders are impossible, we turn to the fan favorite, the wormhole. You've seen Interstellar. You know the analogy. Take a sheet of paper with 2 dots, fold the paper, poke a pencil through. That's an Einstein-Rosen bridge, a shortcut through space-time. 4.1 The exotic matter problem. The geometry of a wormhole is valid in Einstein's equations. The problem is gravity. Gravity wants to crush things. A wormhole throat wants to pinch shut instantly, faster than a photon can cross it. To keep it open, you need an anti-gravity force pushing the walls apart. You need exotic matter, stuff that violates the null energy condition. Essentially, you need matter with negative energy density. We don't have buckets of negative energy lying around. 4.2 2025 developments, F of R gravity and holographic dark energy. However, the literature from 2024 and 2025 has offered a glimmer of hope, specifically through modified gravity. Recent papers published in Nuclear Physics B have looked at something called FR gravity. In standard Einstein theory, gravity is simple curvature R. In F of R theories, we modify that function. The math suggests that if these modified theories are correct, the geometry itself can mimic the effects of exotic matter. We wouldn't need to mine negative energy. The twisting of space-time would provide its own repulsive force to keep the throat open. Furthermore, we've seen studies in 2025 using holographic dark energy. This posits that the dark energy accelerating our universe's expansion could be harnessed to stabilize the wormhole throat. But, and this is a huge but, these are mathematical models. We are using ghost fields to make the equations work. And usually, when you introduce ghosts in physics, you get instability. 5. The quantum frontier, simulation versus reality. While the cosmologists struggle with black holes, the quantum physicists have found a back door. They haven't built a time machine for people, but they have built one for information. 5.1 The Arvidsson-Shuker Protocol. In 2023 and 2024, a team led by David Arvidsson-Schuker and Nicole Junger-Halpern developed a protocol using quantum entanglement. They found a way to simulate a closed time-like curve CTC using quantum teleportation and a process called post-selection. Let me give you the analogy they use. It's the gift problem. Imagine Alice wants to send Bob a gift on day 1, but she won't receive Bob's wish list until day 2. In a normal timeline, she has to guess. If she guesses wrong, she fails. In the quantum protocol, Alice sends a piece of an entangled quantum pair on day 1. On day 2, she gets the list. She then manipulates her half of the entangled pair based on that list. Because of the spooky connection of entanglement, she effectively teleports the correct state back to the particle she sent on day 1. When Bob opens the gift, it matches the list. 5.2 The catch. It's probabilistic. Now, did she change the past? Not exactly. The protocol is probabilistic. Alice has to run the experiment many times and discard all the timelines where the magic didn't happen. This is called post-selection. But here is why this matters. Metrology. We are using this time travel simulation to create better sensors. We can use information from the future of an experiment to optimize the sensors in the past of the experiment. It gives us a non-classical advantage. It solves problems as if time travel occurred without breaking the universe. 6. The crisis of unification, the theory of everything standoff. We desperately want to merge these two worlds, the gravity of wormholes and the entanglement of quantum mechanics. We need a theory of everything. But the desire for this theory can lead us astray. We have to talk about the elephant in the room from late 2024, the Alena Tensor. You might have seen the headlines, "Scientists unify gravity and quantum mechanics. Warp drives are possible." A paper was published proposing the Alena Tensor, claiming to link the curved spacetime of relativity with the flat space of quantum mechanics. It promised easy time travel and warp metrics. By early 2025, it was retracted. Why? Because upon closer inspection, the math fell apart. It equated scalars with vectors, which is like saying 5 degrees Celsius equals north. It was nonsense. Worse, forensic analysis suggested the equations might have been hallucinations generated by AI. This serves as a warning. We cannot shortcut the hard math. As of right now, we still do not have a unified theory. The bridge is not built. 7. Paradoxes and chronology protection. If we ever do build that bridge, we have to deal with the paradoxes. The grandfather paradox. If I go back and kill my grandfather, I'm never born. If I'm never born, I can't go back to kill him. The bootstrap paradox. I go back and give Shakespeare the works of Hamlet. He copies them. Who wrote Hamlet? The information has no origin. How does the universe handle this? 7.1 The Novikov principle versus many worlds. One theory is the Novikov self-consistency principle. This says the universe is a rigid block. You can go back, but you cannot change anything. If you try to shoot your grandfather, the gun jams. If you try to burn the book, it rains. Probability bends to prevent the paradox. The other option is the many worlds interpretation. You kill your grandfather, but you create a new timeline branch. You are now in timeline B. Timeline A, where you were born, is safe. 7.2 Chronology protection and vacuum instability. But in 2025, we got new evidence supporting a different idea, Stephen Hawking's chronology protection conjecture. Hawking basically said, the universe has an immune system. A study on dionic Kerr-Sen black holes, a very complex string theory model, showed that if you try to form a time loop, vacuum fluctuations, quantum noise, start circulating in that loop. Imagine a microphone too close to a speaker. You get a screeching feedback loop. In a time machine, that feedback isn't sound. It's energy. The energy density grows infinitely large the moment the time machine turns on. This creates a firewall that destroys the machine or the traveler before the loop can close. The math suggests the universe creates a singularity of instability to protect the timeline. 8. Conclusion: the the two times. So, where does that leave us? As we close out this talk, remember the two realities. Forward time travel is verified. It is measuring the millimeter difference in gravity at JILA. It is the GPS in your phone. It is the reality that we are all travelers, moving into the future at slightly different rates. Backward time travel remains forbidden. The door to the past is barred by the need for impossible energy, by the instability of the vacuum, and by the sheer stubbornness of causality. But we have learned to simulate it. We can use quantum mechanics to borrow logic from the future to solve the problems of the present. The universe, it seems, is a block universe protected by firewalls. We can look back, we can simulate the past, but we must live forward. Thank you.